Hello. Yeah, today we will study about role of p-value in hypothesis testing. So before starting to discuss about p-value, we will start basic introduction of terminology which is used in computation of p-value for uh, hypothesis test. So first important terminology is population. A population is a very large collection of objects or individuals. For example, uh, all students in the India, list of all students in India, list of all teachers in India. So it will be very difficult to count all students or all teachers in a particular country. So it can be a population. Parameter is any summary number like an average or percentage that describe the entire population. So, parameter is a variable which is used to represent summary of any population. For example, if we have to find out average of students, average number of students in a particular country, or average number of teachers in a particular country, average number of unemployed people in a particular country, so it can be represented by the parameter. Sample is a representative group drawn from the population. So whenever we are selecting a subset of for example, if a population of a country student population, suppose for example, in a country we are finding out total number of students, so we are selecting a small subset of students from that population, and this subset is called sample. So sample is nothing but it is a representative group drawn from a population. We are taking different sample from a given population. So, and statistic, statistics is any summary number like an average or percentage that describe the sample. So what is the difference between parameter and statistics? Parameter is a variable which represents summary of entire population, but statistics uh, s- is a summary of a subset of population, we can say, like average or percentage, which represents to that statistics, yeah, that subset which is drawn from the population. Yeah, statistics is a summary which represents to a sample, but parameter is a summary which represents to a population. Standard deviation is a measure of how spread out numbers are. It means, if suppose we are computing the average number of students in a country, then we can find out deviation from that average to all other value in the sample. So that can be the deviation. Suppose 10 numbers is given, and we are computing the average of that 10 numbers. Now we are trying to find out each what is the difference between average and each individual number, that is represented by standard deviation. The symbol for standard deviation is sigma. This is these are the two symbols. One is sigma, another is s. Sigma represents the standard deviation for population, and s represents the standard deviation for sample. So for sigma equal to, we can use this formula: sigma equal to square root of within a small bracket xi minus mu whole square. So for it is generally represented by square root of 1 by n summation I equal to 1 to n xi minus mu whole square. And standard deviation for sample is written as s equal to square root of 1 by n minus 1 summation I equal to 1 to n within bracket xi minus x bar whole square, where x bar is the average, a summary of a sample which is drawn from population, and mu is the parameter which represents summary of population, entire population. N is the total number inside the population. Total number of population, we can say, yeah, total number of uh, variables in the sample. Making decision. In statistics, there are two ways to determine whether the evidence is likely or unlikely given the initial assumption. uh, in statistics, if suppose some sample data, some population is given, we are drawing the sample from that population and we are computing the summary of that sample, and then we are trying to compare if that summary is matched with the summary that we assume about the population, because it is very difficult to compute the any actual value of parameter which represents the population. So we are making some assumption, and then we are drawing some sample from the population and we are computing the summary average of that sample, and we are trying to match if that average match with the parameter of the population, parameter value of the population. So here, if it is match, it shows likely, and if it is does not match, if a summary of our sample does not match with our assumption, then it is unlikely. So there are two ways to determine whether the evidence is likely or unlikely given the initial assumption. If initial assumption is given, then we have to compute the summary of a sample, yeah, statistics of a sample, and then we have to show if that statistics match with the initial assumption or not. If both match, statistics and initial assumption match, then it evidence is likely. If statistics and initial assumption did not match, then it is unlikely. So there are two ways through which we can we can take the decision. One is we can use critical value approach, which is used in older text, and another approach which is called p-value approach, which is mostly used in research journal, articles and statistical software. So today our focus will be hypothesis test using p-value approach. So what is p-value? P-value is also called probability value. It is nothing but its value always lies between 0 and 1, because we know probability, maximum value of any probability, maximum value of probability is 1 and minimum value of probability is 0. If we are 100% sure about an event, then we say probability is 1. If we are not sure at all about an event, occurrence of an event, then we are saying probability is 0. If we are 50% sure ki this particular event will occur, then probability is zero point 0.5. For example, if suppose we are throwing a coin, so we are sure either head will occur or tail occur. So there is 50% chances of occurring head and 50% chances of occurring tail. So in that case, probability is zero point 0.5. So, p-value is a number between 0 and 1 and interpreted in the following way. If a small p-value, typically if value of p is less than 0.05, then we are rejecting the null hypothesis. In case of, if we are using, suppose we are using p-value uh, to test null, to test if we are using p-value for hypothesis test, then if value of p is less than alpha, then we are rejecting the null hypothesis. If value of p is greater than alpha, then we are accepting null hypothesis. And if value of p is between 0 and it is nearby 0, nearby its value of p is approximately equal to alpha, then we can take any decision. Either we can accept the null hypothesis or we can reject the null hypothesis. It depends on us. Using p value to make a decision. Decision rule based on p value. So before starting all this, we will see some other basic topics which is required here. We have already seen what is hypothesis test in previous video. So what is hypothesis test? It is usually a process which uses sample statistics to test a claim, yeah, to test an assumption about value of a population parameter. So hypothesis test is a process that uses sample statistics to test a claim about the value of the population parameter. For example, an automobile Manufacturer advertises that its new hybrid car has a mean mileage of 50 miles per gallon. To test this claim, a sample would be taken. If the sample mean differ enough from the advertised mean, you can decide the advertisement is wrong. Statistical hypothesis. Statistical hypothesis is a statement or claim about a population parameter. We are making assumption if our population parameter, such as mean, is correct or incorrect. So we need a pair of hypotheses. One hypothesis, one statement represents the claim. Other represents other statement shows the complement of that claim. When one of these hypotheses is false, other must be true. If suppose our null hypothesis is average number, average parameter, mean, yeah, average summary, mu equal to 50. So alternative hypothesis will be mu not equal to 50. So either mu, if mu will be equal to, if suppose from our statistical calculation, uh, we are getting mu equal to 50, it means our hypothesis, our claim that mu equal to 50 is correct. It is accepted. If suppose we are getting mu equal to some other value, instead of 50, then our alternative hypothesis will be accepted. So for hypothesis test, we need a pair of hypothesis, one that represents the claim, other its complements. It means other statement represents the complement of that claim. So when one of these hypotheses is false, other must be true. So it can, we can say it's like a binary statement. If if first statement will be true, then second statement, if our null hypothesis, suppose first statement represents null hypothesis and second statement represents alternative hypothesis. So either our null hypothesis will be true or our alternative hypothesis will be true. At a time, both cannot be true. So it's like a binary decision. Either H0 will be true or HA will be true. Null hypothesis. Null hypothesis is a statistical hypothesis that contains a statement of equality, such as less than or equal to or greater than equal to. So you should always remember, if you are assigning any value to null hypothesis, always remember it should always contain a statement of equality. It means it should be, it cannot be small than, it cannot be greater than, it cannot be not equal to. Always a statement should be like smaller than or equal to, greater than or equal to. It is denoted by H0 symbol. Null hypothesis is always represented by H0 symbol. Alternative hypothesis, a statement of strict inequality. Always assign the value of inequality in the alternative hypothesis. If any statement is given which shows inequality, then represent that claim inside the alternative hypothesis. For example, if I am saying mean is less than 50, so mean is less than 50, always this claim will be represented in alternative hypothesis. But if I am saying mean is less than or equal to 50, then this contains equality. This is it contains a statement of equality. So this statement will be written in null hypothesis. If I am saying mean is greater than 50, so this is inequality, it contains inequality, so it will be represented inside the alternative hypothesis. If I am saying mean is greater than or equal to 50, then it contains equality statements, so it will be represented inside the null hypothesis. If I am saying mean not equal to 50, so this is inequality, it contains inequality statement, so it will be represented in, this claim will be written in the alternative hypothesis. If I am saying mu equal to 50, so this contains equality statement, so this equality statement will be written inside the null hypothesis. So you should always keep in mind kind of statement given in the problem. According to that, you have to assign that claim inside the null hypothesis or alternative hypothesis. So alternative hypothesis must be true if null hypothesis is false. Obviously, it's like a binary decision. If null hypothesis will be true, then alternative hypothesis will be false. If alternative hypothesis will be true, then null hypothesis will be false. Alternative hypothesis is always represented by HA. and it read as H sub A, subscript A. So HA is complement of H0. Yeah, H0 is complementary statement of HA. Stating a hypothesis. To write the null and alternative hypothesis, translate the claim made about the population parameter from verbal statement to a mathematical statement. Write its complement. For example, a null hypothesis is mu is less than or equal to k. An alternative hypothesis is mu is greater than k. So both are complement of each other. There is no common factor between mu between the statement null hypothesis and alternative hypothesis. If null hypothesis mu is greater than or equal to k, the alternative hypothesis will be complement of this. Complement of this is mu is less than k. If null hypothesis is mu equal to k, then alternative hypothesis will be mu not equal to k. It means it contains all the elements which are not common with which is not common with null hypothesis statement. Regardless of which pair of hypothesis you use, you always assume mu equal to k and examine the sampling distribution on the basis of this assumption. Example, stating the null and alternative hypothesis. Write the claim as a mathematical statement, state null and alternative hypothesis, and identify which represents the claim. uh, Stating the null and alternative hypothesis. Suppose school publicizes that the proportion of its students who were involved in at least one extracurricular activity is 61%. So how we will represent this statement in terms of null hypothesis and alternative hypothesis? So here school advertises, yeah, publicizes that proportion of its students who are involved in at least one extracurricular activity is 61%. So this represents equality statement. So here this statement will be written under the null hypothesis. So H0 will be H0 will be P equal to 0.16 because this proportion of its students is represented by P, and its value is 61%. That can be written as 0.61. So this is equality statement, so it is written inside the null hypothesis. So alternative hypothesis will be P not equal to 0.61, which is complement of null hypothesis. Second, a car dealership announces that the mean time of an oil change is less than 15 minutes. So in this statement, this statement shows inequality statement. So this claim will be written under alternative hypothesis. So alternative hypothesis will be mean is represented by mu. So mu is less than 15 minutes. This is inequality condition, so it will be written under the null hypothesis. So what will be the it will be written under the alternative hypothesis. So what will be the null hypothesis? Null hypothesis will be the complement of this. So complement of mu less than 15 is mu greater than or equal to 15 minutes. Next, a company advertises that the mean life of its furnaces is more than 18 years. More than 18 years. So here again it is inequality sign, inequality condition. More than, it means greater than 18 years. So it will come under alternative hypothesis. Mu is greater than 18 years. So null hypothesis will be complement of mu greater than 18 years, which is nothing but mu less than or equal to 18 years. Types of error. No matter which hypothesis represents the claim, always begin the hypothesis test assuming that equality condition in the null hypothesis is true. So we should always assume that equality condition in null hypothesis is true. At the end of the test, one of two decisions will be made. Either we will reject null hypothesis or we will accept null hypothesis. Yeah, we fail to reject null hypothesis because your decision is based on a sample. There is possibility of making wrong decision. Obviously, maybe we are selecting wrong sample. So if we will select wrong sample, then our decision will be wrong. So there is again chances of error. So whenever we are taking correct decision, it means when our null hypothesis is true and we do not reject null hypothesis, then we are taking correct decision. If our null hypothesis is false and we are rejecting that null hypothesis, it is correct decision. But what happen if our null hypothesis is true but we are rejecting that null hypothesis? So it is called type 1 error. So a type 1 error occurs if null hypothesis is rejected when it is true. So type 1 error is represented by symbol alpha. It is also called significance level. Probability of, it is nothing but probability of rejecting null hypothesis when it is true. It is represented by symbol alpha. Type 2 error is probability of accepting null hypothesis when it is actually false. It is represented by symbol beta. So type 2 error occurs if null hypothesis is not rejected when it is false. It means probability of rejecting null hypothesis, probability of accepting null hypothesis when it is false. It is represented by symbol beta. So there are two types of error: type 1 error, type 2 error. Type 1 error represented by alpha, which claims null hypothesis is true but it is rejected falsely. Type 2 error says null hypothesis is false but it is accepted wrongly. So how we will identify type 1 and type 2 error? Here an example is given. The USDA limit for salmonella contamination for chicken is 20%. A meat inspector reports that the chicken produced by a company exceeds the USDA limits. You perform a hypothesis test to determine whether the meat inspector's claim is true. When will a type 1 or type 2 error occur? Which is more serious? So here, what is limit? Limit is USDA limit for salmonella contamination for chicken is 20%. So hypothesis is P should be less than or equal to 0.2 because it is 20%. 20% it should be maximum limit should be 20%. It can be less than 20%, but maximum should be 20%. So USDA limit should for salmonella contamination for chicken is less than or equal to 20%. 20% can be written as 0.20. So P is less than uh, are equal to 0.2, which is written under the null hypothesis, and complement of P less than or equal to 0.2 is P greater than 0.2, which is written under alternative hypothesis. So if suppose this P less than or equal to 0.2 is correct, our null hypothesis is correct, but we are rejecting this, it is called uh, type 1 error. It means suppose chicken meets USDA limit, chicken meets USDA limit, uh, which is represented by null hypothesis. P is less than or equal to 0.20. And here H is P greater than or equal to 0.20. So type 1 error is rejecting null hypothesis when it is true. The actual proportion of contaminated chicken is less than or equal to 0.2, but you decide to reject H0. It is true, but this null hypothesis is true, but we are rejecting null hypothesis. This is type 1 error. If suppose if suppose actual proportion of contaminated chicken is greater than 0.2, but we are accepting that, yeah, we are accepting, but we are if suppose P is greater than 0.2, but still we are not rejecting alternative hypothesis. Type 2 error is failing to reject null hypothesis when it is false. So when it will be false, when null hypothesis will be false, when p will be greater than 0.2. When p will be greater than 0.2, then null hypothesis should be rejected. But we are accepting the null hypothesis, so it is type 2 error. Actual proportion of contaminated chicken is greater than 0.2, but you do not reject null hypothesis. So this is type 2 error. Identifying type 1, type 2 error next. With a type 1 error, you might create a health scare. With type 1 error, you might create a health scare and hurt the sales of chicken producer who are actually meeting the USDA limit. But with type 2 error, you could be allowing chicken that exceeds the USDA contamination limit to sold to the consumer. So which one is more serious? Type 2 error is more serious, because due to type 2 error, many people can face sickness, and they can even their death can be possible. Level of significance. uh, Level of significance is the probability of rejecting null hypothesis wrongly. So your maximum allowable probability of making a type 1 error represents the significance level. It's like a threshold. It means if your probability, it allows the maximum value, your maximum threshold. Under if you will go beyond that, then your null hypothesis will be rejected. The maximum allowable probability of making a type 1 error, it is denoted by alpha or lowercase Greek letter alpha. By setting the level of significance at a small value, you are saying that you want the probability of rejecting a true null hypothesis to be small. If your significance level is small, then chances of error is also small. You are saying that you want the probability of rejecting a true null hypothesis to be small, so a chances of error will be small. If value of alpha will be small, then chances of error will be small. Commonly it is represented by this alpha equal to 0.10, alpha equal to 0.05, and alpha equal to 0.01. So most commonly we are using alpha equal to 0.05. Type 2 error represented by beta, and we don't cover this, it is beyond the scope. Next, a statistical test. After stating the null and alternative hypothesis and specifying the level of significance, a random sample is taken from the population and sample statistics are calculated. The statistics that is compared with the parameter in the null hypothesis is called test statistics. So how we will define test statistics? First, we will take a random sample from a given population. We will compute sample statistics of that sample. Then we will compare that sample statistics with the parameter of the population. So this comparison is called test statistics. For example, we are using mu, p and sigma square to represent population parameters. Sigma is standard deviation, p is the probability, and mu is the mean. And if we are taking some sample from this population and we are comparing and we are computing the summary of that statistics, so x bar represents average of the sample, p represents the probability of sample, and s is the standard deviation of the sample. So sigma square is the variance of a population, and s square is the variance of sample. So comparison between mu and x, it is represented by the z. Standardized test statistic for this is z or t. Comparison between mu and x bar is represented by test statistics z or t. Z, when sample size is greater than or equal to 30, then this is represented by normal distribution. Comparison is represented by normal distribution graph, and which is n is less than sample size, n is less than 30, then we are computing we are using test statistics variable t. If sample size is greater than 30, then we are using sample statistics we are using standardized test statistics variable z, which represents normal distribution. And comparison between p and p cap is represented by test statistics z, and comparison between sigma square and s square represented by test statistics chi square. So What is p-value? P-value is also called probability value. Probability if the null hypothesis is true of obtaining a sample statistics with a value as extreme or more extreme than the one determined from the sample data. So suppose this is our bell curve represented by normal distribution. Okay, and we know area of this curve is cumulative frequency, cumulative probability of all this area is 1. So we are saying this area of this curve is 1, and significance level is the threshold. It means this is, suppose this point is, this is the, this whole area beyond this significance level, this whole area is represented by area alpha. Alpha is the significance level probability of rejecting null hypothesis. This is the rejection region. This is also rejection region, and this whole curve is accepted region. So if suppose your p value will be beyond this limit, if your p value will be right of this or left of this extreme value, then your hypothesis will be, null hypothesis will be rejected. If your p value will be greater than alpha, it means it will lie in this range. It means if the area p value is nothing but area of the curve. If area of the curve, a value of p, probability value, cumulative probability p value is greater than alpha. Alpha is this area. Okay, this area or this area. If value of p, it means your probability value, it can be like this, it can be this area. So if your probability value is greater than value of alpha, then your null hypothesis will be accepted. If value of p, suppose value of p is, suppose value this is your threshold, it means this area suppose represents alpha, and your p value is this one, this area is your p value. So if your p value, yani probability value is less than your significance level alpha, significance level is this area, this whole area. So if p value is less than your significance level rejection region, then area of rejection region, then your hypothesis, null hypothesis will be rejected. If p value will be greater than significance level, then it will be accepted, null hypothesis will be accepted. So probability, if null hypothesis is true, of obtaining a sample statistics, with a value an extreme or more extreme, an extreme or more extreme than one determined from the sample data. It means these two are extreme cases. This alpha is extreme case. If your probability goes beyond this extreme, then it will be rejected. The probability, if null hypothesis is true, of obtaining a sample statistics with a value as extreme or more extreme than the one determined from the sample data, depends on the nature of test. So there are three nature of test. May it is categorized with three types. There are three types of hypothesis test: left-tailed test, right-tailed test, and two-tailed test. So type of test depends on the region of sampling distribution that favors the rejection of null hypothesis. And this region is indicated by alternative hypothesis. The type of test depends on the region of the sampling distribution that favors the rejection of null hypothesis. It means it favors the alternative hypothesis. The type of test depends on the region of sampling distribution that favors alternative hypothesis. Yeah, that favors rejection of null hypothesis. So this region is rejected by alternative hypothesis, or we can say it is rejection region. In other words, we are testing alternative hypothesis. So suppose we have to perform left tail test. Alternative hypothesis, in case of left tail test, alternative hypothesis will be mu less than k for some constant k, and null hypothesis will be mu greater than or equal to k for, and it is represented by this area. This is the test statistics. This is the test statistics, and this whole area is represented by alpha. So P is the area to the left of the standardized test statistics. Whatever test statistics we are computing, suppose after computation of test statistics, value of test statistics is this. So whenever we are computing probability of that test statistics, so this area is the P value of test statistics. Okay, and this is called rejection area. And if this area is less than area represented by significance level alpha, then your null hypothesis will be rejected. If this area is greater than the area represented by null hypothesis, then your null hypothesis will be accepted. Now right tail test. In case of right tail test, your alternative hypothesis will be represented by mu greater than k, and null hypothesis will be mu less than or equal to k. So this is the, for right tail test, test statistic is this point. This is the value of z on x axis. This is represented by z0. This is the test statistics, and area on the right of this test statistics is represented by p. That is, p is nothing but probability of this test statistics. Next, two-tailed test. Alternative hypothesis contains not equal to. So obviously, if alternative is not equal to, so null hypothesis will be equal to. So in this case, either test statistic can be left or right. So if this is the test statistics, the probability of this test statistic will be represented by this value, and probability of this test statistic will be area covered by this test. Probability of test statistics will be represented by this area. So if suppose this it is negative, z statistics is negative, so p is the twice the area to the left of the negative standardized test statistics. Or if suppose we are computing for positive value, positive test statistics, so p is twice the area to the right of the positive standardized test statistics. So in case of two-tail test, whatever we are computing test statistics, we are computing, first step is we have to compute the test statistics, then we have to compute the probability of that test statistics, then we have to make twice of that test statistics, and then compare it with the hypothesis. Identifying the nature of a test. For each claim, state H0 and HA, then determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed test. Sketch a normal sampling distribution and set the area for p-value. Okay. So first you have to define null hypothesis and alternative hypothesis. Then on the basis of this claim, this null and alternative hypothesis, you have to determine this hypothesis is left-tailed, right-tailed, or two-tailed test. After identifying this, you have to compute the probability value of test statistics. And then, for example, a school publishes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So here, your null hypothesis is this p equal to 61%, yeah, 0.61. So p not equal to 0.61. So it is a two-tailed test because it is not equal to, alternative hypothesis not equal to. So if this kind of symbol is used in null hypothesis, so in alternative hypothesis, so we are using two-tailed test. So left side is half p and right side represents half P area. Total area is, this total rejection area is P. Probability of Z is, this is the minus Z test statistic, this is the plus Z test statistic. So we will compute probability of Z and then we will take twice. So this test is, probability of this test is represent half P value, probability of this test is represent half P value, and we will add both, then we will get actual probability value. And if that probability value will be less than alpha, then we will reject the null hypothesis. If that whole probability will be greater than alpha, then we will accept the null hypothesis. Uh, Next, a car dealership announces that mean time for an oil change is less than 15. So here less than symbol is used. So obviously this statement, this claim will be defined inside the alternative hypothesis. So mu, mean time. So it is represented by mu. Mu is less than 15. So if mu is less than 15, it will be represented by left-tailed test. Okay. So we will compute test statistics Z, then we will compute the probability of that test statistic, and then we will find, compare this probability with the significance level alpha. If P value is greater than alpha, then we will accept null hypothesis. If P value is less than alpha, then we will reject the null hypothesis. Next, a company advertises that mean life of its furnaces is more than 18 years. So obviously more than 80 years. It means mu is greater than 18 years. So obviously if greater than symbol is used in alternative hypothesis, then we are using right tail test. So in case of right tail test, we will compute the test statistics, then we will compute probability of that test statistic and then compare that probability with the alpha. If P is greater than alpha, then we will reject the, if P is greater than alpha, then we will accept the null hypothesis. If P is less than alpha, then we will reject the null hypothesis. So this is the main statement on the basis of which we take the decision in case of hypothesis test. And this decision rule is based on P value. If P is less than alpha, then reject null hypothesis. Less than or equal to alpha, then reject null hypothesis. If P is greater than alpha, then we accept the null hypothesis. Here we fail to reject null hypothesis. Null hypothesis. So here is claim and here is decision. Either we reject null hypothesis or we accept null hypothesis. Yeah, we can say we fail to reject null hypothesis. So if claim is S0 and we reject null hypothesis, then it is, there is enough evidence to reject claim. Okay, claim is H0 and reject H0. So there is enough evidence to reject claim. It means there is this is called claim is H0 and reject H0. Then we can say claim is H0, we fail to reject. So there is no problem because claim is H0 and we are accepting H0. So it means there is no enough evidence to reject the claim. We are accepting null hypothesis. Here we are rejecting null hypothesis when null hypothesis true. So this is type 1 error. Claim is HA and we reject H0. So obviously there is enough support, enough evidence to support this claim. So there is no error. But claim is HA, but we are rejecting HA. Yeah, we are accepting H0. Claim is HA, we are accepting H0. So again, this is type 2 error. Interpretation of a decision. You perform a hypothesis test for the following claim. How should you interpret your decision if you reject H0? If you fail to reject H0? H0, for example, a school publicizes that the proportion of students who are involved in at least one extracurricular activity is 61%. So, how should you interpret your decision if you reject null hypothesis, if you fail to reject null hypothesis? So, first we will assign it. If you reject null hypothesis, then you should conclude there is enough evidence to reject. Schools claim that the proportion of students who are involved in at least one extracurricular activity is 61%. There is enough evidence to reject. Schools claim that proportion of students who are involved in at least one extracurricular activity 61%. If you fail to reject null hypothesis, then you should conclude there is not enough evidence to reject the school's claim that proportion of students who are involved in at least one extracurricular activity is 61%. Interpreting the decision. You perform a hypothesis test for following claim. How should you interpret your decision if you reject null hypothesis or if you fail to reject null hypothesis? For example, a car dealership announces that mean time for oil change is less than 15 minutes. So claim is represented by alternative hypothesis. So if you reject null hypothesis, it means if you reject null hypothesis, it means you are accepting this claim. If you fail to reject null hypothesis, it means you are rejecting this claim. So H0 is the mean time of an oil change is greater than or equal to 15 minutes. If you reject null hypothesis, then you should conclude there is enough evidence to support the dealership's claim that mean time for an oil change is less than 15 minutes. If you fail to reject null hypothesis, then you should conclude there is not enough evidence to support the dealer's claim that mean time for oil change is less than 15 minutes, because this is the dealership claim and alternative is greater than or equal to 15. So you fail to reject null hypothesis because you don't have enough evidence to support dealership claim. Steps for hypothesis testing. State the claim mathematically and verbally. This is step 1. Identify the null and alternative hypothesis. Specify the level of significance alpha. Then determine the standardized sampling distribution and sketch its graph. Next, calculate the test statistics and its corresponding standardized test statistics. Add it to the sketch. Obviously, first you define null hypothesis and alternative hypothesis and find out the alpha value. Then determine the standardized sampling distribution and sketch it. So this is the sampling distribution which is represented by this diagram. Calculate the test statistics after computation of test statistics. Suppose value of test statistics is this Z0. We can represent this by using symbol here Z0. Suppose Z0 represents this point. This point is Z0 on the x-axis. Then we are drawing the vertical line which shows the area, rejection area. Steps for hypothesis. Find the p-value. We are computing the p-value of that test statistic Z0. Then use the following decision rule. If p-value is less than or equal to level of significance, then reject the null hypothesis. If p-value is greater than or greater than level of significance, if p-value is greater than level of significance, then we are accepting null hypothesis. Yeah, we fail to reject null hypothesis. If p-value is less than or equal to level of significance alpha, then we are rejecting null hypothesis. So here we are accepting. P is less than or equal to level of significance. So this is false. No means we are checking if P is less than or equal to significance level. So answer is no. It means what? P is greater than level of significance. So if P is greater than level of significance, then we will accept the null hypothesis. If we fail to reject null hypothesis. But if this condition is true, then we will reject null hypothesis. Write a statement to interpret the decision in the context of original claim. So here p-value is the probability, if null hypothesis is true, of obtaining a sample statistics with a value as extreme or more extreme than the one determined from the sample data. So if any sample is more extreme than my level of significance, I have to reject null hypothesis. Obviously, if my sample is more extreme than my level of significance, then I have to reject null hypothesis. Stated a null hypothesis and alternative hypothesis. Identified type 1 type 2 errors. And next we saw how to find out one tail, two tail, and one tail and two tail test statistics, and how to compute p value. Next, our objective is to find the p value and use them to test the mean. Use p value for a z test. We will study the first two topics in this. So to use a p value to make a conclusion in a hypothesis test, compare p value with alpha. If p is less than alpha, then reject as 0. If p is greater than alpha, then we accept the null hypothesis. For example, suppose p value of a hypothesis test is p equal to 0.0237. So what is your decision? If significance level alpha is 0.05, so we know if p value is less than significance level alpha, then we reject null hypothesis. So obviously p is 0.0237, which is less than 0.05, so we will reject null hypothesis. Again, for alpha equal to 0.01, so if p is 0.0237 but significance level is 0.01, so again here p is greater than alpha, so here we will accept the null hypothesis. Finding p value. After determining the hypothesis test, standardized test statistics and test statistics corresponding area, do one of the following to find p value. For a left-tailed test, P equal to area in the left tail. For right-tailed test, P equal to area in right tail. For two-tailed test, P equal to 2 into area in tail of test statistics. So how we will compute the P value? So if suppose test statistics is given in case of left tail or right tail or two tail, so whatever test statistics is obtained after computation, we will computing the probability of that test statistic by computing the area. Find the p-value for a left-tailed hypothesis test with a test statistics of z equal to minus 2.23. Decide whether to reject null hypothesis if the level of significance is alpha equal to 0.01. Alpha equal to 0.01 it is given, and test statistics suppose is uh, its value is, suppose this is graph, sorry, x-axis, and this is our overall probability distribution graph, and suppose this is this value is, suppose this is 0 z. After computation of test statistics, z equal to is minus 2.23. So it means this is our probability p of z. This region is represented by p of z0. Yeah, we can say it is f of z0. Z is z0 is less than or equal to z. So we'll see how to compute this. So you can see here in this diagram, for left tail test, p equal to area in the left tail. And how you will find out this probability value? We can find out this probability with the help of z distribution table. We will see it. See, this is the table. Every statistic book contains the table. So if you will refer this table, our value is z equal to minus 2.23 and alpha equal to 0.01. So I will show you how to compute the probability value p. So minus 2.23, minus 2.23. So minus 2.2 you have to find out in the row. So minus 2.2 is represented by this area. If you will increase this, and you will draw minus 2 point, sorry, so we'll see where is minus 2.2. So this is minus 2.2. We have to compute the probability of minus 2.23. So in row we will check minus 2.2, and in column we will check minus 0.03. So minus 2.23. So we will intersect this row and column. So this column and this row. So this is the probability of Z, and probability of minus 2.23, 0.0129. So this is 0.0129. This is the probability. Now since alpha equal to 0.001, alpha is 0.01, our probability area is 0.0129. So since this value probability is greater than alpha, so we will accept null hypothesis. Yeah, we will fail to reject null hypothesis. Next, find p-value for a two-tailed hypothesis test with a test statistics of z equal to 2.14. Determine whether to reject null hypothesis if the level of significance alpha equal to this. So in this case, z equal to 2.4. So you have to find out z table for positive z. So we will see this z equal to 2.14. In this table, this is the z table, distribution table. This is a cumulative standardized normal distribution table. So z equal to 2 point, z is value of z is 2.14. So we will check 2.1 here. 2.1 is this value, 2.14. So 2.14. So 2.1 row and column 0.04. So this is 2.14. The corresponding intersection cell is 0.9838. So 0.9838, 0.9838 is this whole area. Obviously, you can see here in this diagram, for right tail test we are using positive Z. So this whole area represents 0.9838. 0.9838. So what will be this area? This area, if z equal to 2 point, if suppose this is the z value and z equal to is given 2.14, and probability yani area at this point, area of this graph at this point is 0.9838. So this remaining area will be 1 minus 0.9838. Why? Because this whole area of this graph is considered 1. Cumulative probability is always 1. So cumulative probability is nothing but area of this graph. So if for z equal to 2.14 we are getting 0.9838, then obviously this value will be 1 minus probability of z, this value. So this value is 0.9838. So this value will be 1 minus 0.9838. In this diagram you can see 2.14. So this whole area is 0.9838. So 1 minus 0.9838, because this whole area is 1, and if you subtract from this whole area this portion, you will subtract this area, this whole area, you will get this portion, that is 1 minus 0.983, that is 0.0162. So since it is a two-tailed test, it is clearly mentioned it is a two-tailed hypothesis test. So in case of two-tailed hypothesis, whatever probability we are getting, we are taking we are multiplying that probability with 2. So 2 into 0.0162. So what we will get? We will get 4 0.0324. 0.0324. So since 0.0324 is less than 0.05, 0. This value 0.032 is less than significance level 0.05, so we'll reject null hypothesis. Z test for amine can be used when population is normal and sigma is known, or for any population when the sample size of n is at least 30. Okay, so if minimum population size is 30 or greater than 30, then we are following normal distribution in which sigma is the variance. Test statistics is the sample mean, which is represented by x bar. When population is normal, sigma is known, and sample size is greater than 30, then we are using this formula where x bar is the test statistic, x bar is the test statistics, and z is the standardized test statistic. So standardized test statistics z can be computed with the help of x bar minus mu divided by sigma divided by root n, where sigma by root n is nothing but a standard error, which is represented by sigma with subscript x bar. When n is greater than 30, sample standard deviation s can be substituted for sigma. Using p-value for z test for mean mu. So how we will perform this operation? First of all, we will state the claim mathematically and verbally, identify the null and alternative hypothesis, specify the level of significance. Third step is determine the standardized test statistics z equal to x bar minus mu divided sigma by root n. Find the area that corresponds to z. Then find the p-value on the basis of left tail test, right tail test, or two tail test. For left tail test, P will be area in left tail. For right tail test, P will be area in right tail. For two tail test, it will be P will be equal to 2 into area in any tail of test statistics. Make decision to reject or fail to reject null hypothesis. If P is less than alpha, then reject null hypothesis. If P is greater than or equal to, if P is greater than alpha, then you have to accept null hypothesis. Interpret the decision in the context of original claim. For example, in auto racing, a pit crew claims that its mean pit stop time is less than 13 seconds. A random selection of 32 pit stop time has a sample mean of 12.9 seconds and a standard deviation of 0.9 seconds. Is there enough evidence to support the claim? So in this statement, if you will see carefully, you can see here what is the claim. Claim is mean pit time mean pit time is less than 13. So this is inequality claim. So inequality claim is always represented in alternative hypothesis. So HA will be mu less than 13. So what will be the null hypothesis? Null hypothesis will be mu greater than or equal to 30. Mu greater than or equal to 13. Okay, next sample size is 13. It means n equal to is 32 and sample mean x bar is 12.9 and standard deviation sigma equal to 0.9. and alpha equal to is given 0.01. So you have to compute z. Z is x bar mu minus x bar. It is, yeah, it is x bar minus mu divided by sigma by root x bar minus mu x bar minus mu divided by sigma by root n x bar minus mu divided by sigma by root n. So x bar equal to 12.9, mu is 13 and sigma is 0.19 and root n is root 32. So after computation, you are getting the value of z. Test statistics z is minus, you are getting test statistics minus 0.298, where x bar 12.9 given, mu is 13 and this is your sigma by root n is 32. So after calculation of this, you are getting z equal to minus 2.98. Now you have to find out the probability value of minus z point minus 2.98. So we will see it, minus 2.98 minus 2.98, sorry, so minus 2.98 minus 2.9, you will see here minus 2.9 here and 0.08 is this value. So 2.98, you will see what is the value, 2.98. Nine eight seven six five four three two 109 98654321009. So 0.0014. This is the value, 0.0014 according to this test. 0.0014. So 0. You can see in this table, probability of z is 0.0014, which is on the left side, and since 0.0014 is 0.0014 is greater, no, 0.0014 is less than alpha. This is the alpha. This value is alpha. So P equal to 0.0014 is less than alpha, so we are rejecting null hypothesis. At the 1% level of significance, you have sufficient evidence to support the claim that mean pit stop time is less than 13 seconds. So it means we are rejecting null hypothesis. It means we are supporting the claim of auto racing. Next, hypothesis using p-value. We will see next example. The National Institute of Diabetes and Digestive and Kidney Diseases reports that the average cost of bariatric weight loss surgery is $22,500. You think this information is incorrect. You randomly select 30 bariatric surgery patient and find that the average cost of their surgeries is $21,545 with a standard deviation of $3,015. Is there enough evidence to support your claim at alpha equal to 0.05? Use p-value approach. So again, what is claim? National Institute of Diabetes and Digestive and Kidney Diseases report that average cost of bariatric surgery is, it means mu equal to, it is given mu equal to dollar 22,500. So this is equality statement. So we will represent this statement in the null hypothesis. So null hypothesis is this: if this is equality, so obviously alternative will be complement of this statement, which is mu not equal to 22,500. Alpha equal to is given 0.05 and x bar is given, x bar equal to 21,545 and sigma is 3015. Size of sample size is 30. So after computation we are getting minus 1.73. So again we will find the value of minus 1.73. We will see what is the value of minus 1.73 in Z table. Minus 1.73 minus 1.73. This is minus 1.7 and this is column में we will see this 0.03. So we will intersect this column and row 1.73. So this is the value 0.0418. 0.0418. 0.0418. 0.0418. You can see here p value is 0.0418. So since this is not equal to, obviously this means it is a two-tail test. So two-tail test के case में whatever we will get the computation probability, whatever we will compute the p value of z, then we'll take double of that. We'll multiply that p value with 2. So actual p will be 2 into 0.0418. That is equal to 0.0836. Since 0.0836 is greater than 0.05, so null hypothesis will be accepted. It means mu equal to $22,500 will be accepted. This claim is accepted, supported. So at the 5% level of significance, there is no sufficient evidence to support the claim that mean cost of bariatric surgery is different from 22,500. Means we have no enough evidence to support alternative hypothesis. Okay. So